if our objective is to compare the homogeneity of the two slopes, so that may be tested by using the parametric test, that is the F test. But students, in order to apply the F test for comparing the slopes of the two regression coefficients, we would have to assume that the samples that are being drawn from the two populations, those populations are assumed to be normal. In case the two populations are non-normal, we can make use of the Hollander procedure that was being proposed by Hollander to test the homogeneity of the two slopes. The procedure for testing the homogeneity of slopes will take the form that under step number 1, we are considering that the two models are being taken as, for example, y1j, which is alpha 1 plus beta 1 x1j plus the errors. But the point I would like to highlight here is that under y1j, we are assuming that x11 has to be less than or equal to x12 and so on. So they are being taken in an order of magnitude from smallest to the largest. And similarly, students, for model 2, for data set 2, y2j is alpha 2 plus beta 2 x2j plus the error. And here again, we are assuming that x21 is less than or equal to x22 and so on, it is less than or equal to x2n2. Now, as we know that our objective is to compare the two slopes of the two regression models. So if we can, students, test the equality of the two slopes by employing the two-tailed as well as one-tailed or directional hypothesis. So for a two-tailed test, if our objective is to compare that h0 beta 1 equal to beta 2 against the alternative that they are not equal, so we can employ the two-tailed test. And for the one-tailed test, we can test the a particular directional relationship between beta 1 and beta 2. For instance, beta 1 is less than beta 2 or beta 1 is greater than beta 2. Under step 2, we will be taking alpha being 5%, 1% or 2%. Under test statistic, we require that the number of observation pairs in the two groups has to be the same and there be an even number of pairs. So students, we will be discarding those values under x or y which are greater in number. Consequently, the first step is to discard the observation randomly from one or both groups as necessary to meet the requirement to making them even number of pairs. The next step is to set the resulting number of observation in each group to be equal to 2 times n. From the data of set 1, form n pairs by pairing x1j with x1j plus n, where j is 1, 2, so on up to n. Compute n slope estimators for group 1 by employing the formula u1j, that is equal to y1j plus n minus y1j divided by x1j plus 1 minus x1j, where j is 1, 2, so on up to n. Then from the data of set 2, we'll be repeating the same. We need to form n pairs by pairing x2t with x2t plus n, where j is 1, 2, so on up to n. We compute n slopes estimators for the group 2 using the same formula u2t equal to y2t plus n minus y2t divided by x2t plus n minus x2t. Once we are done with the calculation of the slope estimators for group 1 and group 2, we randomly pair the u1j's with the u2t's so that each u appears in one and only one pair. So they are the distinct pairs actually. Under step number 8, we are required to compute n differences of the form z, where the u1j is to be subtracted from u2t. We designate these n differences by z1, z2, so on up to zn. Once we have calculated all these kind of z's on the basis of the pairs between u1j's and u2t's, the procedure from this point is exactly identical to the procedure for Wilcoxon matching pair signed rank test. That is, the z's will be replaced by d's. Then we rank the absolute values of z's from smallest to the largest. We assign to each of the resulting ranks the sign of the difference. We compute t plus, which is the sum of the ranks of the positive signs. We calculate t minus, which are the sum of the ranks for the negative signs. Then the test statistics will be t plus or t minus depending on our alternative hypothesis. Under step number 4, which is a critical region, if it is a two-sided test, then let t be the t plus or t minus, whichever is smaller out of these. We reject each knot at alpha level of significance if the calculated value of t is smaller than or equal to tabulated t for n and alpha by 2. So this particular value, critical value, students, that will be obtained from the Wilcoxon sign rank test critical table. If beta 1 is less than beta 2, then sufficiently small values of t plus will lead us to the rejection of null hypothesis. Whereas if our alternative hypothesis is of greater than type, then sufficiently small values of t minus will lead us to the rejection of the null hypothesis. So students, this is the entire procedure for testing the equality or homogeneity of the two slopes for the two regression models.